Should we start? Shall we start?
Yes, sir.
I was going. Saurav, are you there? Saurav Mandal, are you there? Okay. So let us discuss what we have. So we are discussing on the single line diagram preprocess, SLD preprocess, right? So any query from the last class. Yesterday we discussed about the bus bar scheme selection. That what is the total available type of the bus bar schemes we have. So we discussed that we have total 6 type of the bus bar schemes here, right? So any query regarding the advantage and disadvantage of the bus bar schemes, any query regarding that? The single bus bar schemes that we discussed yesterday, and then single bus bar with bus section, then main and transfer bus bar system scheme, and why those bus bar system schemes comes into the practice, that also we discussed. So any query regarding that, why those bus bar systems comes into the practice, why those bus bar schemes are required, why different bus bar schemes are required. I need the participant like who are active. So please do, if anyone have any query, let me know. If no, so we can proceed to the next topic. And if you don't have any query, let me ask one questions to all of you. Could anyone tell me in the double bus bar system scheme or double main and transfer bus bar system scheme, why we use the bus coupler?
Rerouting the power from one bus to other bus.
To maintain the potential difference zero.
Potential for the bus bar.
Okay,
so to maintain the potential difference zero. Okay, this is one reply. Second reply.
Rerouting the power from one bus to other bus.
To route. Come again. To route. Okay. Then
To rerouting the power.
Third.
Feeding the power when
feeding
the power to the other bus. Feeding the power, sir, when the one bus is under maintenance, so feeding the power to the other feeders.
Feeding the power to the other bus. Okay, then any other query?
Equal potential, sir. Bus coupler required for the equal potential in the bus 1 and bus 2, sir.
Equal potential, okay then. Yeah, I think there's
for redundancy purpose.
To transfer the power from one bus to another bus for bus transfer application, equalize voltage.
And for redundancy purpose also.
Redundancy purpose also. Out of that different reply, different response, if I need to tell what is the exact purpose, and to be very close to the operations, so I can tell the use of the bus coupler. The bus coupler provide on load isolator switching. I again repeat, the bus coupler provide on-load isolator switching. This is the exact purpose that bus coupler is doing, and in order to achieve the on-load isolator switchings, the bus coupler couple two bus, so that between both bus the voltage difference would be 0, or both bus would be on the equal voltage, equal potentials, so that when they are on the equal potentials, then this on-load isolator switching would be possible. So isn't it the correct reply or the close reply? The bus coupler provide on-load isolator switching, irrespective of telling equalized voltage, taking transformer and bus transfer applications, other things. Let you evaluate your reply with this sentence. Which one is the most suitable reply? On-load isolator switching seems more accurate, right?
Yes, sir.
This is what, due to this reason only we are using the bus coupler, otherwise no on-load isolator switches, because we do not want any kind of the bus interruptions, any kind of the power interruptions, Yeah, perfect to the point. This is what I'm trying to tell, Partha. Perfect to the point. If anyone asking why bus coupler required, so as a engineer, you should tell bus coupler provide on-load isolator switching. This is what the to the point reply. Okay, so we discussed about the double bus bar system schemes, double main and transfer bus bar schemes, and 1.5 breaker bus system scheme is started. So I hope those bus bar schemes, what are the advantage and disadvantages is clear, right? No query regarding that. Let us quickly discuss about how the switching operations done at the site by the operator. Means we have installed the substations. Let me take one substations view as well. 1 second. Let me give it. Yeah. Yes. So here let me take this one as well. So suppose here we have a substation site. I'm just trying to take how the operations to be done at the site. So just taking the exact site photo of a substations. So here we have the control room building, our control building. In the control building, the operator are sitting, and in front of the operator, they have the like SCADA computer engineering, and they have the control relay panels placed inside the control building, and they have all the equipment switchgear installed outside. So how the equipment operations to be executed by the operator. So let us discuss just sake of the knowledge, only because it is done at the site by the operator. But just since we are discussing the bus bar scheme, so let us discuss about the switching scheme as well, the equipment operation sequence as well, to be honest, how that would be operated. Since you are going to make this single line diagram, so this point we can club in the discussion. So let us take like if we go with the single bus bar scheme, if we have, in that case, if like we have a single bus bar, and after that we have a circuit breaker, and then there is outgoing feeders. So to operate or to feed this line, just need to close the circuit breaker. This is what can be done if we have single bus bar schemes. If in case we have single bus bar, so here no, just simple operations, just close the circuit breaker, and power supply is started. So this is up to 33 kilo voltage that this bus bar schemes we take. And when we go above 33 kilo voltage in the power transmission, at that voltage we take single bus bar with the with the with the transfer bus coupler, right? Transfer bus with the transfer bus are SMT, single main and transfer bus bar scheme, single main and transfer bus bar schemes. So in that, what we are doing, suppose let us take one typical feeder. So we have a common bus bar, and then there is a outgoing feeder. So from the bus bar, we have discussed that we have to take the isolators. So we are taking the isolator, the bus isolator. After that, we have the circuit breaker, and then again we have the line side isolators, and then it is going. And then again, since we are using the transfer bus, due to that reason, we have to use the transfer isolator. And then we have a reserve or transfer bus bar means we are transferring the power from main bus to this transfer bus. And to charge the transfer bus from the main bus bar, we have to take one additional circuit, which is called as transfer bus coupler circuit. So here we have the isolators, and after that we have circuit breaker, and then again CT here, and then again we have the isolator and connecting to this transfer bus. let us take the any outgoing line. So between two isolators, we have to take the outgoing line, and in the outgoing line to the exit side, we place the CT, and then we have to place the uh, wave traps or line trap in order to get the power line communications, and then capacitor voltage transformer, CVT. CVT, this is a typical feeder, typical circuit that we take, and after that we take the surge arresters, and then there is a outgoing feeder here we have. So in the normal, so let us go with first, we go with the normal operations. In the normal operations, here we have the main bus bar, and here we have the transfer bus bar. We are using the transfer bus bar to provide the backup to the circuit breaker. This is why we are using the transfer bus and transfer bus coupler bay as well. This is called the transfer bus coupler bay. This is why we are using the transfer bus coupler bay. And here we have the transfer bus. So the normal operations, the transfer bus coupler bay would be in the open state, in the open positions by the operator, by the substation operator. And transfer bus bar, since it is open, so there is no charge or no voltage on the transfer bus. And in that case, if they need to on this or close the circuit for this feeder 1, let us take a feeder 1, any typical feeder. So I'm taking this feeder name as feeder 1. So how this switch or operate the equipment in which sequence the operator will do at the site, how they are going to operate. Again, this would be in the open positions, right? This entire circuit is in the open position. Then in that case, they can close the isolators first, right? The first they need to close the isolators. So this one or this
Yes,
one,
sir.
this one or this one, any isolator they can take. So let us go with the bus isolators. So the first bus isolator, this equipment, the operator going to operate at the site. Then operator will operate this equipment.
Yes, sir. Sir,
Then,
putting a name, sir. Sir, 89A and 89L,
yeah,
right?
let us
So easily understand, yes, sir.
Yeah. So 89A here,
A. 89L.
L here.
L.
Since this
Yes.
is line, so here we have to use the earthing switch as well, right?
Yes, sir.
Okay. And this is 89T, right? 89T.
T.
And this is 89, what we can use here. A,
sir. A. Yes, A. A1, sir. Yeah, A.
No, not A here. A already we have taken here. So A we cannot take. Any other we have to take 89. B we can do.
B, yeah, C. Yes. And this is the C.
We could not take the similar equipment numbering, equipment designations. Otherwise, it will be confused. So we have to change the number. So A, B, C like that. So yeah, in the normal operations, they can close the 39A. So let me change my pen color so that I can close here. So here, just closing the isolators. How they close the isolators? How they close the isolators from the control room building? How they close this?
Yes.
How they close this?
Using the BCU, yeah, SAS operations.
Yeah, using the BCU, right? So they are closing.
Yes,
they are closing this, and this is open state. This is all in the open state. This is, and then in the last. So first, this A, and second this 39A, the operator going to close, and then in the third,
then after that
they can close
is the breaker one.
Let us take
breaker.
So 52.
52.
We can take here, and this is feeder 1, so we can take like 52.
52,
1 we can take, right? Like
means
that.
22.
1.
Yes, sir.
So 52, 1 they can, and then in the last they can close the 52, 1. This is how the operator will, you are making the SLD, you are not going to operate the equipment at the site, but I'm taking, you are making the SLD, so how that SLD would be operated at the site by the operator. Ghazi Muhammad, please switch off your video. And then this is normal operation by the operator then. in this through this route the power will flow. This is normal
sir.
power flow
Power flow.
directions. Case number 2, you have prepared this single line diagram. Now if they need to take the 50, suppose the fault happened, they need to take breaker under maintenance conditions. In that case they require the breaker under maintenance. Are
Yes, sir.
any fault happen near to the circuit breaker, and in that case how they will reroute the power supply from main circuit to the transfer circuit. So how they will do this?
89B operation first, then 89C
Yeah.
operation.
So the first would be 89B would be closed.
Yes.
Second 89C
89C is on.
could be closed.
Then after TBC breaker
Third-
will be closed.
Third, one second.
TBC breaker closed.
One second. Could I close the 89T as well here? Since we are
No,
closing
sir.
all the isolators, so could I close the isolator here?
No.
Yeah, we cannot close this. We cannot close these isolators because we are closing the isolators. So one side we have, suppose this is a 132 kilo voltage circuit.
Yes.
So at this side we have 132 kilo voltage, and this side we have 0 kilo voltage. So
Zero potential. sir.
yes, since we know that isolator is no load device, so it should be operated under no load conditions, means when current flowing is 0. So, but here, since due to the voltage difference, current will start flowing. Due to that reason, we cannot operate 89T. So first of all, the operator have to close the breaker. This breaker they have to close. So once this breaker is closed, so whatever the voltage they have on this main bus bar, suppose this is 32 kV, so same voltage will reach to transfer bus, and the transfer bus will have the same voltage level. So the same voltage level now it will reach here. So
Yes, sir.
so here 132 kilo voltage and here 132 kilo voltage. So in the last, the operator need to close the 89T isolators, right? This would be their fourth sequence of operations. Am I clear? 1, 2, 3. Set 1, 2, 3, 4. Right?
Yes. Then after the
And-
breaker of 52 breaker open.
Yeah. Then fifth, they have to open they have closed. So now earlier it was the power flow directions. Earlier it was the power flow directions. Now this particular feeder one have the two power flow directions. One coming from here, second coming from here to here, going to transfer bus, and through the transfer
Yes, sir.
it is going to the transfer isolators. Then it is flowing like that it is flowing. So since they have two parallel power flow directions, thereafter the operator need to open. Now so far they are closing all the switch gears, now they are coming to open. So the operator now need to open the 52 circuit breaker. Once this circuit breaker is open, thereafter they can close any of the isolators, like they can open the bus isolators 6, and then they can open the line isolator 7. This is how the operator at the site going to operate the equipment, right? And they can take this breaker under maintenance. And once this breaker is healthy, the fault is fixed, then they again close the circuit breaker, and then again they have to open this transfer bus coupler bill, so that
So,
yeah.
sir, I have one query. While opening the isolator, it is not required to have the zero potential difference in the
This isolator you were telling,
89L and 89A
89L,
and 89A.
89.
Since we are opening the 50 to 1 after closing the 50 TBC. TBC. So we have to open the isolator first. No?
This 89L you were telling you have to open first.
Yeah, I'm just a bit confused on it. Shall I open the isolator or first or breaker first? This is my query. I'm a bit confused since the isolator has to operate on the zero potential.
Actually, this isolator initially it was in the closed position.
Hmm.
earlier it was in the closed position, right?
Yes, sir.
It is not open position. It was the closed position, right?
Yeah. The current is flowing through this
Yeah, current was flowing through this earlier. So
earlier.
if you are opening the circuit breaker here, circuit breaker now if you are opening, so here you are getting the open circuit inside the circuit breaker, right? And now you are not closing the isolators, you are opening their contacts, right? Opening their contacts, not closing, not I'm not
Okay.
attempting to close the circuit.
That is my query. While the opening the isolator, it should not be. It is not a condition to have the both terminal at the same potential. Only for the closing the isolator.
See, since when you are closing, then it is required, but when you are opening, then you can open the circuit breaker, and after that you can attempt to open the isolators.
Fine,
But
sir.
when you are closing, so it is required
It
because
is required. While opening is not required.
yeah, it was not.
May not be required.
Yeah, may not be
Thank
required. Are any O&M engineer who are at the site, they can also add on their experience if any O&M engineer, how they are going to they do actually at the site. Any O&M engineer. Yeah, closing sequence circuit breaker is last equipment to close or open. Yes, closing sequence is circuit breaker is last.
No. First we have to open the circuit breaker. Then only after that only we have to open the isolator.
Come again. Fully.
First we have to open the circuit breaker. Okay, because isolator should open on that the no load condition. Okay, if the circuit breaker is in closed position, we should not open the isolator. First we have to open the circuit breaker. Then only we have to open the. After that only we have to open the isolator. This is a sequence.
So you were telling Puli that first of all, this circuit.
We have to open the. Yeah, we have to open the circuit breaker.
Yeah, this breaker you have to open. After that, you can open these isolators and this.
Yes. Yes.
Okay, this is okay. This is what we have.
Yeah.
This is what.
Yeah, because isolator is a just kind of switch. It is not the it don't have the any making and breaking capacity. So first that is why so that we have to open the breaker first. After that only we have to open the isolator. This is a general standard sequence of the isolator operation.
Okay.
What do you say? I mean that any.
Yeah, that's fine. Breaker open isolator.
That was my query. So I right now it's clear while the opening the isolator, it should not be. It may not be satisfy the condition of the zero potential difference.
Yeah, that zero potential is concerned only for the
only for the closing, not
closing.
It's clear. I'm sorry, I'm not in the operation or design of this one, so this might be just silly query from my side.
No problem, Dinesh, at all. This is why we are here, so to discuss all our thoughts. So that's fine.
Thank you, sir. Thank you, Poli.
Thank you. Thanks too.
Yeah, sequence of operations we are discussing, whether this is what we are discussing, the sequence of operation procedures. Okay, let us take one another type. Yeah, okay. So
sir, anyone asking the TBC applications are the same as a bus coupler application is answering that question, sir.
Yeah, so the same, the TBC application is to provide backup to the circuit breaker. This is just the
okay, means yeah, not a on-load operation for the isolators.
No.
Yeah, both question, both merge answer to the
yeah, provide backup to the circuit breaker.
Okay, only okay, sir. Thank you, sir.
Yes. Yeah, backup to main bay, this is correct. Yes. So the use of the transfer bus and the transfer bus coupler bay for the use of both is to provide backup to main bay circuit breaker. Okay. Harshit, is it clear to you?
Yes, sir. Clear.
Yeah. Okay. So now since we discuss a lot of things and different engineers have different opinion on that. So during the operations at the site, there could be different knowledge level of the operators. So there could be mistake by those operator as well when they're operating the equipment at the site. So in order to avoid the mistakes at the site, when we design any substations, we provide fully interlocking in the substations so that there should not be any wrong equipment switching or equipment operations. Because if there is any wrong equipment operations or equipment switching, in in that case, there would be unnecessary arcing and the operator equipment, the operator as well as the equipment may damage. So to avoid those situations, those mistakes, we do fully interlocking in the equipment. So due to that reason, we have the interlock schemes, in the service stations. And this interlock schemes is given in the service distance control relay panel schematic drawing, so that we do the interlock. So let us see.
Can you please repeat that word, sir? The interlock why?
See, we discuss about the equipment operation sequence, right? So
Yes, sir.
but when we are reaching at the site, different operator may have different knowledge. All the operator are not the skilled operators, and there could be a probability of human error. There could be a probability of human error for the wrong equipment operation sequence. So as we discuss here, in order to close, let us suppose this here, we discuss that in order to close these isolators or in order to close this circuit breaker. So what is in order to close this circuit breaker, what is the criteria you have to satisfy? Both this isolator and this isolator should be in the closed conditions, right? Then you can close the circuit breaker, correct now? Like
Yes.
first we close the isolators and after that we close the circuit breaker. This is what the sequence that we follow. This is what we discussed now.
Yes, sir.
Yes.
One here.
89A or
Yeah.
1B.
So here, if you
close.
see, we discussed that when equipment is normally operated, so first this isolator is closed, and when we are closing these isolators, we are ensuring that the circuit breaker is in the open position, right?
Open condition. Yes, sir.
And that second, we discussed that we are closing these line isolators at 89L. So during the closing of these line isolators, we are again ensuring that the circuit breaker is in the open position, open
Yes.
status. So how and once and after closing the both isolators, then we, in the last, if you see here, we have done 3 marking, we are closing the circuit breaker. So how that to be done at the site, and means if these operations we are doing at the site, so there is a probability of the human error, the mistake of the equipment operations. So to avoid those human error and to achieve the equipment protection and the operation protections, we provide the interlocking in this equipment operations. Okay.
Yes, sir.
Who asked the query?
Okay, sir. Yes, sir. Yes, sir. I got it.
Interlocking schemes, and these interlocking schemes is given in the control relay panel schematics drawing, which is prepared by the control relay panel manufacturers. So this anyway, this is we will discuss in the protection module number 12. But again, since we are discussing the switching schemes, so if I take this interlock scheme, this understanding would be easy. So due to that reason, due to that purpose only, I'm taking this interlocking scheme during the SLD preparations. Otherwise, this is the part of the protection modules. Since we are like discussing equipment switchings, due to that reason, we can discuss this interlock schemes. So if you see here, I have taken a control relay panel. This is the panel that we install inside the control building, and each bay there have their own control and the protection panel. So I have taken this control relay protection panel schematics drawings, It's total 63 page drawing. And if we go in the last positions in the last page, few manufacturer put in the last, few manufacturer put it in the beginning. So again, you have to see that what they have indicated this this interlock schemes. So if you see here, so what the manufacturer do here, that they provide the single line diagram, and then they provide the isolated interlock logics, like each and every how their interlocks and how the closing and opening to be done at the site. So this interlock logic is prepared in the control schematics drawings. So let us discuss about the interlock logic, that how this to be done actually, because we are just discussing that first we will do this, second we will do this, but operator could do the reverse cycle as well. So to avoid the reverse cycle, there should be interlock, so that the probability of the fault human error would be very much less. So coming to the interlock logic, and after discussing this, we will come on the SLD drawing preparations. So here, to ensure that all disconnectors, all earthing switches, and all circuit breakers operate, are switched in or switched out from the service in the correct sequence, so the substation shall be provided with a full interlock scheme for the safety of equipment operating person and each piece of equipment as well, each equipment protection as well. So these interlocking schemes are provided in the substation control relay protection schematic drawings. So let us see about that. The interlocking system ensure that specific conditions are met to operate equipment safely. This is a 2 point, a very close reply to the point reply, that why we use the interlocking. So interlocking system ensure that a specific condition have been met, are met to operate a equipment safely. So how this specific conditions have been met, how they ensure this. So for that they have the logics. So for they have the logics. Through the logic, they ensure that specific conditions have been met or have been satisfied, and equipment could be operated now. So for example, I need to operate this isolator, so we need to ensure that breaker is in open positions. I need to I operate this isolator at 39L, so we need to ensure that my like breaker is in the open positions. At the same time, my earthing switch is in the again open conditions, right? Then only I
Yes,
can
sir.
isolate, then only I can operate the isolators. So this is my specific conditions that need to be met. So this interlock system ensure that specific conditions are met to operate equipment safely. Now this interlocking at the substation site to be provided or can be provided in two ways. There would be mechanical interlock. The mechanical interlocking mainly provided between the disconnector and the earthing switch. Like here we have the disconnectors and earthing switch. So between this equipment we provide the mechanical interlock, that if we need to operate this disconnector, so this earthing switch should be in the open positions. They are mechanically interlocked. So it could be provided as a mechanical, or the interlocking could be provided with electrical interlocking. And for the electrical interlocking, again we take two methods. This electrical interlocking can be done by the hardware cables. So each and every equipment have the auxiliary contact, auxiliaries and no NC contact. So if you see, when we purchase the equipment, we mention that this equipment must have 10 NO, 10 NC, 8 NO, 8 NC contact. So why we are mentioning those contact and why those auxiliary contacts we required? Because we wanted to do a electrical interlocking. We wanted to do the cabling between the equipment by using that auxiliary switches, auxiliary NO and NC contact, normally open and normally closed contacts. So through that we can do the electrical hardware by taking the 2.5 or 4 square mm copper cable, so that we can do the hardware cable connections between the equipment. and parallelly by the software interlocking as well. So by the software interlocking also, this to be done inside the
Yes,
relay
sir.
panels, and
Yeah.
those relays communicate with each other, and those communications we called a specific name. This name is called goose communications, and this communication is done on the protocol of 61850 protocols. So now, and this is the point number one. We discussed 2-3 points here. So first point we discussed that to avoid any uh, wrong operations of the equipment, there should be interlock logic. This interlock logic ensure that specific conditions are met to operate equipment safely. This is what uh, we discussed. Point one. Point two we discussed. Point number three we discussed that this interlocking can be provided or can be achieved in two ways. This is point number three we discussed. And point number four we discussed this electrical interlocking again divided into two parts, by cable parallelly and by
Yes.
the software.
Software.
Uh,
Yes.
This is fourth topic this we discussed. And now, as we have seen here, that here we have the control building and here we have the equipment. So operator sitting in the control building. So we usually what we do, we keep equipment in the remote mode, by the selector switch. And from all equipment, what we do, from all the equipment, from like here, the operator is sitting in front of the operator, they have the engineering computer, and here operator is sitting in front of the operator, they have the control and relay panels, CRP panels. They also have. So now suppose here we have transformer bay, one transformer bay, two transformer bay, and here we have the line bay. So from each bay, this is actually transformer bay, this is elevated transformer bay. From each one, from each bay, from each equipment, we do the cabling. So from isolators, from circuit breaker, from CT, each and everything, we do the cabling in the substations. And for this cabling purpose, we prepare the cable schedules. And this cable schedule have the three part: the cable between the switchyard, cable from the switchyard to the control relay panel, cable between the control relay panel for the panel to panel
Interconnection between.
inter-panel wiring. So we do the cablings, and all the equipment status there, we take for the cables inside the control relay panels, and we have a specific device. This device called as the bay control unit. This is BCU. Sometimes we call as the relay as well, BCU relay, right? So bay control unit. The work of this bay control unit is to control each and every bay. So each and every bay, they will have their own dedicated bay control unit. So all the equipment, their status could be monitored in the BCU relay inside the control room building by the operators. They no need to go physically walking, and they need to go physically checking each and every equipment status, so they can easily monitor inside the BCU relay, right? So each particular bay, each and every bay has a bay control unit installed in that base control panel, in that particular bay control panel, and each bay will have the control panel as well. So here I have taken a control relay panel manufacturer drawing. So if you see here, this is a 300 megawatt, and this is a line bay. This is a line bay control panel. If you see 220 kV line bay control panel, so each line bay will have the control panel, right?
Yes, sir.
Yeah, bay control unit is also called the bay kiosk. No, Ramkumar, bay kiosk is bay Marcelin kiosk. So this is installed at the site. So what we are doing, that in each and every bay near to the circuit breaker, we take one marshalling kiosk,
BMK box.
which is called as the bay marshalling kiosk. So
BM.
what we do
Yes.
that instead of taking the cable from all equipment,
Isolators.
to the control room building, all the cables we take from equipment to the bay marshalling kiosk, and from the bay marshalling kiosk we can take a multi-core cables, and through the multi-core cable we can take like 2, 3, 4 cables just, and we can connect to the control relay panels. So this bay marshalling kiosk just reducing the number of the cable requirement from the switchyard to the control room building. Okay, so now, so each bay will have their own BCU, and each bay will have their own control panel as well, and all equipment is wired from the outdoor switchyard to the bay control unit, and the bay control unit takes those input. This is important line, so please focus here. Let me highlight as well. What I highlight? Yeah, so please focus here. Let me change the color. Or okay, no problem here. Yeah, so each bay, here, and BCU takes. So as I'm telling here that from each equipment we are taking cable connecting to the BCU. So now another statement here, the BCU takes those inputs which is coming from the equipment, those inputs as the binary inputs. Since this is relay, so relay operate on the binary numbers.
Yes,
Right?
sir.
What is binary? Binary means
0 and 1.
0
and
and 1. What is analog? Analog means zeros to like 4 to 20 milliampere, like that. We can say analog signals, binary signals, digital signals. So BCU takes those input as the binary inputs in form of the 0 and 1, and the electrical interlock logic will be developed. This logic interlock, which we are discussing about the interlock. So this logic will be developed inside the BCU relay, inside the BCU, and this logic developed using the logic gates.
And or not.
Equipment switching can be done, and equipment switching can be done remotely from the BCU if it satisfy all the interlock logic criteria. So I think I'm clear with
Yes,
this.
sir.
With this, so why we require the interlock? This is the point number 1. Point number 2, we discuss how the interlock could be provided. So there is two-way, mechanical and electrical, and we discussed that electrical could be again two-way, cables and software, and we discussed that where this interlock to be developed. So this interlock to be developed inside the BCU, and all the equipment from the auxiliary contact we will wire till the BCU, and BCU take those inputs as the binary inputs, right? And if
Yes, sir.
and to create the interlocks, we use the logic gates. So let us see some logic gates, and before that let us see the BCU, how it looks like. So here I have taken the BCU picture. I have taken the both view, the front view and the rear view or back side view of the BCU relay. So if you see here, let me take this inside. So whatever the way I have, if you see the way line that we developed here, so this exactly way mimic we developed inside the BCU relay as well. Here, if you see in this we have developed the mimic, right? Could you see this mimic?
Yes, sir.
Here, so here we have in
Yes,
this BCU, this is the Siemens make BCU, and here so we have two main bus bar, right? In this particular picture,
Yes, sir.
two main bus bar. This isolator is in the closed position, so it is closed here. This isolator is in open position, so it is indicating as open. Then we have earthing switch, which is in the open positions. Then circuit breakers, CT, isolators, earthing switch, open conditions, VT. So exactly the same single line diagram we developed here. So through that we can monitor what is the equipment status. And if you see here, we have the equipment on opening and closing switch as well, right? Could you see here?
Yes, sir.
So by selecting those switch, here we have the like change options. We can select the switch gears, and by using this press buttons, we can press and we can switch on or switch off the equipment remotely at the
Yes.
remotely from the control building, right?
Yes, sir.
Am I clear here? Remotely from, and if you see here, we have the LED indicators here. So all the LED indicators is also indicating what is the status of the equipment. And all the equipments from here, we are taking the wiring. So here we have there like terminal block as well, through that we can wire. And here we have the communications port as well, through that we can take this BCU into communications. We can communicate through the substation SCADA as well. Use hardware interlocking from direct contact from each equipment, not all recommended to use auxiliary contact. Yeah, they use the hardware interlocking. All the criticals, they do hardware's interlocking from direct contact. Sukumar. So they do this. So now, so this is my front end. So through that, as I told you, that each bay have the BCU and all equipment wire to the BCU and PCU. Like through the BCU, we can. So here. So I have mentioned here again what the BCU do in the substation. So the main function of the BCU is to monitor the whole system remotely. Monitor. So here you can see they are indicating the status LED. They have light, LED light. So the monitor of the whole system remotely and control the substations from the remote. If you see here, we have the switch to control this equipment from remotely. Sometimes up to 33 kilovoltage project till 33 kilovoltage. The protection function, like we have the overcurrent and earthfall protections till 33 kilovoltage level. So those protections functions also we can implement inside the BCU only. In that conditions, this BCU called as the bay control and protection unit. In the short we call this is BCPU then. BCPU. BCPU. I'll show you this one real project example as well. So just give me 1 second.
Sir, opening and closing command of the equipment is also goes from the BCU or something else?
Yeah, that could be routed from the BCU.
So can we operate circuit breaker from BCU or from other equipment?
From the BCU. From the BCU. I'll show you one BCPU. Just one single line diagram is ready.
Sir, I saw in a grid they are using TNC panel to operate. So what is the function of BCU in that?
PLC panel?
Trip and close command. TNC switch.
Yeah, that could be done. Then this could be done at the local, at the substation level, the trip normal close. So this is at the equipment level, we have this TNC switch so that we can operate this. So yeah, BCU is a microprocessor, correct? Yeah, it is a microprocessor based relay. How it takes analog inputs, how this conversions happens. This conversions happens through they have analog to this converters as well. So they converts anyway. This are part we will be covering inside the protection model, but so you don't worry about that. Okay. So here, if you see here, this is a 33 kilovoltage feeder. And from this 33 kilovoltage feeder, we have the BCU. But the name of this BCU is BCPU. So means this bay control protection unit. So it means inside this BCU, we have used the overcurrent and earth fault relay as well. So if you see here inside the BCU, we have used the 50, 51, 50, and 51 and disturbance recorder. This all we have used inside the BCU, right? So in that case, this BCU called as the BCPU, and BCU has the binary inputs, analog input, binary output, control switches, display, as we can see here, display, and LED communications, LEDs and the communication port as well. Am I clear so far? Am I clear so far?
Yes, sir. Clear, sir.
Am I clear so far?
Yes, sir.
So now, as we
Yes, sir.
discussed that LED BCU take the logic gate, so let us see about the logic gate. Even though this logic gate in the engineering tab at the BTech time in the semester 1 or semester 2, we have done a study. Like in my case, I have a study. I think it is in semester 1. I'm not sure.
Yes, sir. Physics.
Not physics. That's
Yeah, this is in
the physics. Right?
STLD.
Microprocessor.
In the physics.
There is
Microprocessor.
logic gates.
Microprocessor wave.
Yeah, in the physics, but this is the part of the BTech, the first year syllabus as well, the microprocessors, where they talk about a lot about the logic gates. At that moment, the understanding was not so much wide that while we are discussing this, but this is very
It was like STLD subject for us, like switching logic design something.
yeah, switching logic design, yes. So here you see here, before going to the scheme discussion, so what I will do here that I will take one project and that scheme I will discuss. But before discussing their schemes, here let me recall, or let us recall what we have discussed in the college time. So we have this kind of the logic gates, like this is the NC symbol of the logic gates, and this is the IC symbols. So since we are following the IEC standards, so if you see in the drawing as well, they have taken this kind of the symbols and this kind of the symbols and right, but this symbols, this AND gate could be represented by this symbol as well.
Yes, sir.
Right, so this is NC symbol, this is the IC symbol. The only difference of symbol is the standards, but function is the similar. So sometimes we use sometimes I have seen in some control schematics drawing that even though that if you see here we have mentioned and R, if you see here sometimes we have mentioned R as well. Let me go from the beginning. So if you see here, sometimes we have mentioned and we have mentioned R as well, but some control schematics they do not mention R and like R as like this. So they mention R like this, greater than or equal to 1. So if you are seeing greater than or equal to 1 in any control schematics drawing, you have to think that this is R gate. So and R jar XNOR or XR, and this is not gate. Okay, and I hope everyone remember how they work. So in the AND gate means both inputs should be high, should be 1. This is what we have discussed.
Yes,
right?
sir.
This table basically we discuss. Let me take this table as well. 1 second. Let me do. Yeah, I think this picture, if not clear here, we discuss about the truth table, right? That we have discussed that
Yes.
A and B. So if A and B 0, then output would be 0. A 0, so 0. Out of 2, if any 0, then again output 0. A and B, A 0, A1, B 0, then again output 0. And if both is 1, then only the output would be 1. Here, this is what the AND gate telling. So means if we need to take output, then both inputs should be high. Both inputs should be 1, right? Then only we can get the
Yes, sir.
output from this AND gate. And if in case we have the OR gate, so in that case, out of 2, if any one is high, then output would be high. So this is what the OR gate telling 0, 0, then 0, but 0, 1, then 1, 1, 0, then 1, and 1, 1, then again 1. So out of 2, if any one input is coming, it will provide output, right? And are not.
Yes, sir.
So I'm not going about the truth table, and I assume that you all know about the truth tables and the
Yes,
interlock.
sir.
So now going to this project, now this is what the ultimate aim. So in this particular project, I have double main bus bar schemes, So this single main and transfer I have already discussed. So let us take the next bus bar scheme, which is the double main bus bar schemes. And here we have the bus coupler here. Mohammed Jabir, please come closer. Yeah, here back to this double main and transfer bus bar schemes. Sorry, double main bus bar
Yes,
scheme.
sir.
So how to operate? So here we have the main bus 1, main bus 2. So bus CVTs, do not focus about the bus CVT because those are the just bus voltage transformers. So my focus is on this power supply to this 220 kV feeder. So how we are going to do the power supply and operate the equipment for this 220 kV feeder. So here we have a line bay and plus we have a bus coupler bay, right?
Yes, sir.
Now we need to close. So for each and every equipment switching, at a time we operate one equipment first of all. So at a time one equipment we are going to operate, not push all the buttons, not operate all the equipment. At a time one equipment. So now I'm operating this isolators. So as we discussed that when we are going to charge any feeder, first of all we have to close this isolators. So now we are going to
Yes,
close
sir.
the isolators, and suppose as we already discussed here, we will closing the isolators first. So first closing the isolators. So in order to close the isolators, what conditions we should satisfy? What is the condition that need to satisfy? Let us take this bus 1 isolators 89A2. So in order to close this isolator, what should be conditions to be satisfied? Then only a operator can close this isolator.
252 breaker will be open conditions, first of all.
Just 1 second. 252 breakers will be open. So here I have this interlock logic. I want to compare both together. Could I take the snapshot from just 1 second?
Yes.
I just want to compare both. It's better we can take the snapshot. Let me take the snapshot. Yeah. Since we are discussing the single and diagram preparations, but we have discussed about the bus bar schemes, switching scheme. Due to that reason, we are discussing on the interlock. But our for this model, our objective is to prepare the SLD, and that we will discuss. But whatever the interlink topic, that also I want to touch. Due to that reason, I'm taking this topic. Yeah.
Yes, sir.
Now to close this isolators, we wanted to close this isolator close. The operator inside the substations want to close this isolator. So what should be the conditions then that need to be satisfied?
252
And
open
here if you see, when they are going to close this isolator, so what they have to do, operator have to push the close request, right? Close button. The operator in the VCU, they have to first give the close request, right? Close button they have to close request they have to give. This is the criteria number 1, right?
Yes,
So,
sir.
so what I can take one AND gate. I can take one AND gate, right? I can take one AND gate, and I'm taking 2 inputs from that one AND gate. The first input I can take that operator need to give the close request, right? This is the one
Yes, sir.
close request, and then means AND gate work when this and this both input 1, then this provide the output, then this provide the output. So when they are putting the close request, then this bit high, and they are getting one this go in this gate, but
Yes.
but again, to close these isolators, we have to satisfy the criteria. So what is my criteria now?
252 will be open.
And please keep in the mind, this is my double main bus bar scheme. Double main.
Okay,
Sir,
sir.
we can directly close it now.
Sorry?
No.
We have to
We
open
can directly
the
close it because of a zero potential difference.
I have a no position of the breakers. So first of all, require the breaker positions. So we are close the isolator or not close.
before closing the isolator, we have to open the earth switch.
Yeah, there is a criteria that since we discuss any conceptual bias first of all, okay, but this is what we discuss in conceptual in general terms, but this is why we are discussing the interlock schemes. There are so many other interlock conditions they have to satisfy. Means, as I told that when closing the isolator, the breaker need to be closed in the last, means initially breaker should be in the open status. So these conditions have to satisfy. Earthing switch should be in the open positions. So these conditions have to satisfy it. Okay. So we do not think that we can directly close because the current is flowing 0, but we have to ensure that breaker is in the open positions, right?
Yes, sir.
So then first is my close request. So this input, second input will come through the interlock. The second input come to the interlock. So when my interlock is permissible or interlock satisfy healthy, so one and this one, then it is going to issue the closure order to the isolators. This VCU. So now, so we had one is clear, but we are discussing about this second input to this AND gate. So what is my second input to the AND gate? So first of all, if you see any earthing switch in that bay, so that earthing switch must be in the open position. This is the very first requirement. So if you see here, bus coupler 89 AE open positions. Since this is double main bus bar schemes, we are both bus, we are also coupled to each other. So due to that reason, since both bus coupled to each other, so this bus coupler circuit is also coming into this feeder circuit as well.
Yes, sir.
Due to that reason, this bus coupler circuit also coming to the feeder circuit as well. Similarly, when you are working for this bus bar scheme, main and transfer bus bar schemes, since you are operating this bay feeder number 1, but you have to take into interlock this transfer bus coupler circuit as well. In every bay, the circuit will come into the interlock. Similarly, if you are working for double main bus bar scheme, then the bus coupler with every circuit come into the interlocking sequence. So particular your bay plus bus coupler bay, particular your bay plus the transfer bus coupler bay. This interlocking we have to satisfy. I hope I am clear that why the bus coupler and TBC, because it is interlinked with your bay as well, due to that reason. So that could not be. So now here we have the earthing switch. So first we are bus BC stand for the bus coupler. 89 AE is open position. So this open positions, and again this one we can take this also in the open positions. So this isolator's earthing switch is in the open positions. So 89 bus coupler in open positions. So that's fine. It is in the open positions. So this signal going to the AND gate here now. This is our criteria 1, but there would be so many other criteria. So there would be so many other criteria as well. So let us see other criteria as well. So when we are closing these isolators 89A2, at the same time, here we have circuit breaker. So this circuit breaker should be in the open position, right? This open, and this, let me mark here as well. So this earthing switch again we are putting in the open position, right?
Open position. Yes, sir.
Open positions. Here again we are putting in the open positions. So this again in the open position. So here 252. This screen is visible, right? These words are visible.
Yes, sir. Readable, sir. Yes, visible, sir. Readable, sir.
89B visible. So 252 is this circuit breaker. So this circuit breaker is in the open positions. Yeah, this is criteria 1, but there are so many other criteria. So we are taking with other logic gates. So now we have one logic gate. We have one logic gate, which is the AND logic gate. So keep in the mind, AND logic gate work when both input is high, then this output would be high. So AND gate here. So my breaker is open positions. Yeah, that that is open positions. This is if it is in open positions. So this is status 1, and at the same time, when I'm initially charging, so this 89B I'm putting in the open positions. Initially charging. So this 89B2 also is in the open positions. So when closing to this isolators, this breaker and this isolator, both ensuring that both are in the open positions. So if both 1, then output AND gate, then output would be 1. So now 1, but again we are using the OR gate, means there are other conditions also that we have to see. So what I'm getting here, so now I have the OR gate. So again, OR gate have the 2 inputs, 1 input, 1 coming here. So if 1 is coming here, I have the OR gate, so it means output is 1 here, right?
Yes.
Right. So 1 I'm getting here, 1 I'm getting here, I have the OR gate, so means I can bypass other conditions and I can directly close the isolators. So let us go to the isolator approaching. So OR gate, so 1 coming here, so 1 here input, so output of the OR gate is 1. So now I have the AND gate, so 1 here. So AND gate means again we are taking 2 inputs, so other means bus coupler 89 AE open positions. So this bus coupler 89 AE again in the open positions. So again, right, like here to be specific, the when review the drawing, we have to write here 89 AE1 and 89 AE2, so that this will not duplicate 89 AE1 and here 89 AE2, like that. So open positions, it is coming to the open positions. So AND gate, so 1 here and 1 here. So it means output would be 1, output 1. Here I have taken this isolator earthing, this bus coupler earthing switch already in the open position. So 1 coming from here, 1 coming from here. So output would be 1. So output 1 means my interlock is permissible. This information is coming.
Operation for.
Yeah. So again I have the AND gate, means 1 coming from here, and then yeah, we have to ensure this my isolator should be in the remote mode.
Yes, sir.
Should be in the remote mode, because we are operating from the
Remote side.
BCU. We are operating from the BCU, so there should be the remote mode, because equipment also have the TNC switch, so TNC switch like trip neutral close, right? So
Yes, sir.
That equipment could be tested locally
Trip and close.
from
Trip and close switch, sir.
from the switchyard level. So that should be in the equipment should be in the remote mode. So when it is in the remote mode, 1 here and 1 again coming here, then output is my 1, output 1 going to here, and again I'm getting the close request I have already done. So 1 here and 1 here, then I can close the isolators. This is very simple logic, right?
Yeah. Yes, sir. Understood.
This is how you need to review the interlock logic when you are doing review the CRP control schematics. So even though I'm discussing the SLD, but I'm telling you how to review the CRP schematics interlock logic as well, right? So a few portion of the protection models also touching. Now again, this is criteria number 1. Other criteria how this isolator could be closed. So now let us see here. Let us see here now. Here it is coming the
Transfer switching.
Isolator on-load switching. So now,
yes, sir.
Now in the on-load switching, my circuit breaker should be in the closed position, right?
Yes, sir.
Circuit breaker should be in the closed positions. On-load switching,
yes,
right? By the
way, isolator also switching.
Let us assume that this earlier from the double main bus bar we have closed this one isolators earlier we have closed, right? But now we wanted to switch these isolators. So in order to close these isolators, what the criteria we have to satisfy means this breaker should be in the closed position. Now if you see here 52 in the closed positions. Now there are so many inputs. So again, AND gate we are taking. So in this case, all the inputs should be high. Not in this case, we have 2 inputs. So that only 2, 1, 1, then 1. But all should be 1, then output would be 1. So here 1, if my breaker is closed. Then 89B2 in the closed positions. Yes, this would be in the closed
isolator.
Okay? This isolator should be in the closed positions. Only then here we will get the 220
potential.
Here we will get the potentials, and here we have the potentials, and then only we can do the on-load switching of these isolators. So these isolators also should be in the closed positions, right? So breaker closed isolator.
Yes, sir.
And now this bus coupler also will coming into this into this circuit closing. My bus coupler breaker should be in the closed positions. My bus coupler isolators, all isolators should be in the closed positions, right? So when I satisfy all this bus coupler and breaker and bus isolator is in the closed positions, everyone getting one output, then it will one input, then it will give the one output, right? So one here I have R gate. So either I can take this positions or either I can take this positions, right? Right. So is it okay? Because here I have R gate. So any two, if input is high, then output would be high because we have the R gate. So now we have the AND gate. So one we are taking from this, and then one we have taken that my earthing switch is in the open positions. One here, one here, then output is one. Here my earthing switch is in the open positions. So it's my input one here. So it is providing output one here. And now if output one here, so it means interlock is permissible. So we are getting this now. Then one here, and isolator have been in the remote mode selected by the BCU. Then one here getting, then AND gate. So it means it will provide output as one. And we have already given through the close request through the by manually pressing the close command in the BCU. So output close request already given. So one here, and then we can close the isolators, right? Is it
Yes, sir.
okay? Is this interlock is easy to understand? I don't think there should be
Yes,
any.
sir.
Sir, 252 circuit breaker opening position is already checked before. Then why we check again?
Because we are doing this isolator need to be closed in two conditions, right? One, initially we are charging the bill. Second, suppose we have taken this isolator initially, and now we need to close this disconnector or this isolators for the on-load switching. So at that case also we need to close this isolators. So we are taking the interlock to close the isolator. So we are taking both conditions. One, without load charging, without load closing. Second, we are taking on-load closing. Okay, so that is why here we have taken the R gate. Am I clear?
Sir, where is the 18 and
Sir,
18
isolator.
18 and AE? There is the 18 and AE, sir.
13 and A is here, this bus coupler earthing switch.
18 and AE.
Yeah, 18 and A. This 18 and LE2, this 18 and LE2, I will interlock with this line isolators. Okay.
No, AE, why we are calling as AE, sir? 18 and AE.
18 and A is here, na? This one and this one. Let me go back to that. Let me go back to the drawing. Here you can see 18 and AE here.
Why we are calling as AE, sir? You mean that earthing?
You can call your name. We don't have any issue in that because here we have 89A. This isolator name is 89A. This is earthing switch.
Earthing
Total
switch.
we have taken the AE.
Okay, sir.
There is no any logic. The grid,
Alright, sir.
the grid switch their numbering or switch numbering I will discuss. You don't worry about that.
Okay, sir. Okay.
But whatever switch numbering is mentioned in the drawing, you take that switch numbering and through that you check the interlock logic. Okay.
Okay, sir. Okay.
So this, to be honest, this should be 89A AE2, right? No, this should be 89AE2 and this should be 89AE1 because here we have 89AE2 and AE1. Sorry, AE2.
No, sir. This is the BE2.
Yeah, BE2. So yeah, this is 89AE2. Yeah, 89. So this could be written as 89AE2.
AE1.
Why, sir? 2 times will be checked, sir. So this is the confusion, sir. Already, sir, they check the position, sir, and last one is the second time will be check the position, sir.
Yeah, this could be written as 89BE then. BE. BE, na? It should be BE.
Yes, sir. Yes, sir. It should be B.
Yeah, BE, no, here B. As I told you, no, this point already I have taken in my discussion. To be ideally, it should be 89 AE2 and this should be 89 BE2. AE2 here and BE2 here. The same that we have in the bus coupler.
Yes, sir.
Okay. Yeah. Any other doubt? Someone is always saying yes, sir. Yes, sir. Could you please step into me? Yeah. So. Yeah. Any query in that? I'm just waiting for 1 minute to take one of your queries. Okay, so if no any query, we can proceed to the next. So now we have the close order. Now, in order to get the open order, how to open the isolators? How to open the isolator? How we can open the isolator? So first of all, we have to give the open request, right? This is the input
Yes,
one,
sir.
open request. So when this is the input number one, and input number two, the same conditions again we have to follow. My same as we have discussed here, the same we have to follow. Then only we can open the isolators, because we wanted to open the isolator again under no load conditions. Due to that reason, the same conditions again we have to follow. Okay. So this is for the isolators, and if we go to the next isolator 89L. So for the isolator 89L, if you see here, I have the LE earthing switch. So this earthing switch should be in the open conditions. So my breaker is in the, for my line isolators. So for my breaker should be in the open positions. My line earthing switch should be in the open positions. When satisfy both criteria, then AND gate, then getting output as 1, and then interlock is permissible. So output 1, and then my this line isolator should be in the remote mode, this getting 1 here and 1 here, and then taking output from this AND gate and connecting to this AND gate, and I'm putting my close request. So when providing the close request, so this is 1 here and 1 other getting from this. So 1 and 1, the output would be 1, and we can close the line isolators. Similarly, same criteria. When I want to open the isolators, now I think Dinesh, you can correlate with your query as well here. If I want to open the isolators, so first what we have to do, my breaker should be in the open position, right, Dinesh?
Yes, sir. Yes, sir.
So my breaker is in the open positions. My line earthing switch is in the open positions. So when getting both 1 and 1, then output getting 1, and then 1 is feeding to the AND gate. So this 1, and when my line isolator is in the remote mode, then both 1, then output getting 1. So this 1 feeding to this AND gate, my open request, and 1 we are taking, and then we can open the line isolators. Similarly, if I want to close the earthing switch, so in order to close the earthing switch, what is the criteria that need to be satisfied? First of all, my isolator should be in the open positions, right? So my line isolator is in the open positions, and then there should not be any line voltage, no load voltage conditions, right? Right now, if any voltage coming, so isolate earthing switch is not allowed to close. So there should be not any load. Then only in this, if both criteria, both input is 1 1 getting 1 1, then this interlock is permissible. If you see here, back to this interlock schemes. If you see here, a few we have done. So like this isolator open positions, bus coupler, earthing switch, breaker, isolator open positions, close positions. This all interlocking we are doing with help of the cables. And if you see here, bus bar in the closed positions, T9A closed positions, bus coupler 39B open positions. So this all is my bus coupler bay. So now this bus coupler bay BCU will communicate with my line bay BCU, right now?
Yes, sir.
So since now here relay 1 BCU is communicating with the bus another bay BCU, so this communication is happening on a software communications on a protocols through the host communications. Due to that reason here, if you see this particular manufacturer have used this and at the rate, they're indicating that this interlocking and these inputs coming not through the hardware, through the softwares communication. So if you see here, they have indicated at the rate through the goose communications, and star this interlocking should be done through the hardwires. So they have taken here the star. So if star means they have to take bus coupler, earthing switch, hardware, this interlocking, and from the respective bay, all the cables coming to the equipment. So here, all the equipment position directly coming to that particular BCU. But here to here, they are doing the interlocks, the cable interlocks. Okay, so this point already I have mentioned here that this communications to be done by the cable and by the ghost communications through the software. So now coming to the if we see the breaker closing. So how we can close the breaker? What is the criteria need to satisfy in order to close the breaker?
Any isolator 289A or 289B isolator on conditions.
So first of all, in order to close the isolator, the remote closing of the isolator, what need to be done? Let us take the snapshot. My trip circuit, the circuit breaker trip coil should be healthy, right? Correct. This is AND gate here. So this is one, my trip circuit should be healthy, so that when I'm attempting to close, when I'm closing the circuit breaker, if any fault happened, my trip circuit is healthy, so breaker could initiate the tripping. So this all, due to that reason, the trip coil or trip circuit should be healthy. So this breaker need to satisfy this criteria. Then 86A and 86B. What is the meaning of 86A and 86B? Not OPTD means not operated. What is this?
Isolators.
No, yaar. Isolator is 89.
Okay. Master trip.
This is
That's all.
this is 86. Let me erase this. 86.
Master trip.
Yeah, this is
Master relay,
yeah,
not operator.
Master trip.
master trip relay, and we have seen that all the relay communicate with the master trip relay, and master trip relay issue the tripping command to the breaker. So master trip relay should not be operated. So this is what the next criteria means. My breaker trip coil healthy, there should not be any tripping or fault happen, and master trip relay should not be operated. So that criteria need to be satisfied. And then if you see here, any of two, since this is double main bus bar scheme, here we have two main bus bar scheme, double main bus bar scheme we have. So we have isolator from the bus, and then we have isolator from the bus 2 as well. as well. So any of two isolators should be closed, right?
Yes, sir.
So if you see here, they have written here 289A2 or 289B2 is in the closed position. So any of two of isolator, which bus we are selecting, that isolator should be in the closed positions. So in the closed position. So this one getting one, isolator is in the closed positions getting one. Bus bar not operated means there should not any bus bar protection, that should also not operated, so getting one. So if all the input getting one, then this AND gate providing the output one, it means my interlock is permissible now. So getting one, and now taking 52 we are taking under remote mode. So remote mode again it is one. So one here and one here. Then AND gate output would be one. So this one is now further extended to here. My breaker, yes, now I have given the close request to the breaker. So one getting here, and now close request given. So one getting here. So the output would be one, and my breaker is now closed, right? And if I wanted
Yes,
to
sir.
open the breakers, so again the same sequence we have to again repeat. So again we have to give the open request, open, getting one here, and then breaker is under remote mode, right?
Yes, sir.
If my breaker is remote mode, I'm putting the open request, just two input, right?
Yes, sir.
Just two input. Now I'm not taking the isolators, opening, closing, this or nothing. This need to be done into the isolators, that they are again, because isolator is no load device. Due to that reason, they are again ensuring that my breaker is in the open positions, or if not in the isolators, breaker is not in the open positions, then at least my second bus disconnector is in the closed positions. Then only we can operate the isolators. But here, in case of the breaker, not like that. We can directly give the open command to the breaker. So just getting breaker under remote mode, open request, and directly we can open the circuit breaker. Right. So since we discuss here,
So what is this? So what is this remote mode? Why should this would be in the remote mode? Can you please explain remote mode?
here, if you check here in the BCU, you have the keypad here, right?
Yes, yes.
So actually, what happens? Let me go to the site now.
That is the breaker selector switch, local and remote switch.
Yeah, here we have the equipment, right?
Sir, inside the equipment there is a selector switch,
Yes.
local and remote.
Yes. So that I'm coming here. So here we have the substation at the site. Now here we have the selector switch. Because suppose you do not have a selector switch and you want to take the local testing of the equipment. So how you will do the testing of the equipment? You will not go each and every time to the control building, and you are not going to operate equipment from the control room building. There should be a facility available that you can operate equipment closely, locally from the equipment level as well. So here we have a selector switch given in the equipment, and through that selector switch you can select that whether equipment is in which mode. So that equipment from here we need to select that it is in the remote mode, right?
Yes, sir.
Control mode, like local control, what can I say, local remote, like that. What is the selector switch?
Yeah, it's a local
Yes,
and
sir,
remote.
local and remote.
Local and
manual or remote. Manual and auto.
manual or auto,
Yeah.
local or remote. So if I need to switch the selector switch into remote position or in the auto position, okay?
Okay. So remote means we can operate that equipment by any end remotely.
Yes, by BCU. By BCU, sir.
Okay. Okay.
Remote,
Okay, sir. Understood.
remotely by BCU, okay?
Sir, one doubt.
Yeah.
If in case if we need to trip the circuit breaker manually from the switchgear, then is it possible as per the interlock logic?
So if you
I
are
think possible.
Yeah.
But the logic condition will not satisfy if we are manually doing from that one. Then the remote mode is not enable as one. No.
Have you seen here, like we have the open request, so you can open the isolator from here, breaker from here. You can open from here.
But it is an and logic. We need to get one from remote mode also.
So here we have the remote mode, and here you give the open request to the breaker, and then you can open the breaker.
But for that remote mode, where will it will get the remote mode status one if we are operating from manually from the switchyard position?
So you have the selector switch there also. So I think you can do from that TNC selector switch you have. At the equipment, you trip neutral close. So through that you can trip the circuit breaker, open circuit breaker at the equipment level locally from the switchyard.
That I understand. That's right. But when we are checking the logic, how it was satisfying.
Sir, I answering that question.
Yeah.
They logic only for the BCU operation, not a manual operation. Okay. Hello.
Okay.
Rahul.
You mean
These
yes,
interlocks or everything is the operation for the local remote mode operation, not a local operation.
So Rahul, whenever you are operating in the manual mode, your BCU is bypassed at all. You have to do the equipment level control. You can't do anything through the BCU or SCADA or anywhere.
Okay. Thank you.
See, we are operating the equipment, Rahul, through this interlock. Through the operations of the equipment, we are discussing all these things. Okay. If any fault happening, the relay will issue the tripping command to the circuit breaker in the service. And suppose you wanted to do any local testing, you have a TNC switch at the breaker, and you can do the testing by using that switch. Okay. So this what we are what we are discussing. This is discussing how the equipment normally would be operated through the BCU.
Sir.
Okay.
Excuse me, I have a question. One doubt, sir. Whether what do you mean by bus bar not operated means, sir?
Yeah.
Hello.
Come again.
Sir, here to write bus bar not operated. What do you mean by means bus bar not operated means, sir?
The bus bar protection. Bus bar protection is not operated. So here there's my trip coil should be healthy. There should not be any master trip relay operated, and at the same time the bus bar protection relay should not be operated. Prakash?
Yes, sir. Yes, sir.
Yeah. Then only you can close the breaker. And then only interlock is permissible. Okay.
Sir, but where is bus bar not operated means there are relays, relay.
Yeah, yes, relay. Yes, correct. Bus bar protection relay. Yes.
Okay, sir. Okay, sir. Thank you, sir.
Yeah. Why the line isolator status is not mentioned? Line isolator status. Line isolator status. Let us see this.
Not required, sir. Because the operation of the breaker, what line isolators not required the positions.
So they are telling here that the line isolator should be in the closed position.
Yes, sir.
They telling 89L, sir. 89L, sir.
Yeah, so 89L closed positions.
Required, sir, or not, sir? 89L.
Oh, means what can I say?
Not required, sir.
But why?
Due to the we are operating the breaker, not an isolator.
Actually,
So
in interlock, na 89L is required. Yeah, 89L is required for the interlock of
required.
KB closing.
So if you see here, I think with the nine isolators, we have taken the breaker into the open position. Okay, so this is case one. Yeah, but if we are adding one more conditions, then there is no any harm in that. We can take that one. So in this AND gate, we can extend to this AND gate. We can extend to this AND gate anywhere. So this AND gate we can extend, and we can take as the 89L should be in the
close position.
close position right now.
Yes, sir.
I think we can take that. Yeah. Yes. So this 89L we can take under close positions. It would be more means we are covering the isolators as well. So I think it would be more. Yeah, it is good. Yeah, we can take the line isolator under close positions. That would be better. Tips. Please, Alok, please mute yourself. The participant who have the background noise, please do not unmute your noise coming into the class. Yeah, nice to mention completion positions closed, not closed. Yeah, correct, closed. Correct, yeah. Correct, yeah, Sukumar, you clearly highlighted. So closed here, D and D here, closed. Closed means yes, it has been closed. Correct. Okay, yeah, so yes, we can give the line isolators that is no problem in that or no harm in that. We can take this line isolators in the closed positions. Okay. Yeah, any other query regarding the breaker closing? Any other query regarding breaker closing? I hope I'm okay with the isolator closings, breaker closings, right? Earthing switch closing. Please let me know if anyone have any query. If no, we can extend to the next topic.
Okay, sir.
Okay.
Okay, so since we discussed that we are taking equipment like switchings, we are discussing that if the fault happening on the bus bar, so how the power we are rerouting. If the fault happening to the breaker, then how we are taking the TBC way, and through that way we are rerouting the power. So taking the same concept, keeping the same concept in the mind when you are preparing the electrical installation layout drawing. Suppose I have taken the electrical installation drawing. Keep the same concept in the mind that you are telling this when the bus bar fault happening or when the breaker fault happening, we need to do the maintenance. So how those maintenance to be done at the site. So for that reason, when you are preparing the electrical installation layout drawing, in that layout drawing, you have to provide the access route or approach route or maintenance route. So as in the bus bar schemes selections, we discuss bus bar and breaker maintenance in case of fault, right? Or in case of scheduled maintenance. So we are discussing the maintenance. So how those maintenance to be done? For the maintenance, we require the maintenance vehicle, right? I have taken here the snapshot of the maintenance vehicle, right? So those maintenance vehicle, we have to take near to the breaker and near to the bus bar. So what we do when we prepare the layout drawing, we try to keep the road around the bus bars, so that whenever we required any maintenance on the bus bar, through the maintenance vehicle, we can do this activity at the site. So for the maintenance at the site, when preparing the equipment installations layout drawing, we need to keep in mind that approach road around the bus bars and until the breaker. In the breaker, I have a criteria. If my breaker is up to 33 kilovoltage, 1110 kilovoltage, 132 kilovoltage, means up to 132 kilovoltage breaker if we have. In that case, the road not required to the circuit breaker. But when the breaker voltage level going above 132 kilovoltage, means for 220 kilovoltage and above, in that case, the breaker becomes bulky. It is not handled manually by the operator, and we require the like crane, hydra to like handle the breakers. So if in case the breaker voltage level is greater than 220, greater than or equal to 220 kilovoltage, would be, so bus bar and breaker would be required for the maintenance vehicle access. So from 220 kilovoltage and above, since the breaker would have you so near the circuit breaker, again the approach road would also be required. So I have taken, to support my statement, I have taken extract from the CBIP manual. This manuals we refer to design the substations. So if you refer the CBIP manuals to design the substations, that manual also referring the same concept. 245 kilovoltage and higher voltage output circuit breaker generally necessity the provision of the approach road for the breaker maintenance. So when we prepare the layout drawing, please keep in the mind around the bus bars and around the, like in this snapshot, here we have the circuit breaker. So during the drawing review, I have given the comment that it would be better if this road we can extend till the breakers, so that near the vehicle can go near to the breaker, and then we can do easily the breaker maintenance. So after that, we discussed that even though instead of putting the road, we have the hydra, they have the boom, so that boom length could be extended. So through the extended boom, this equipment could be left, could be lifted, so that here during the layout preparations we have not given the road provision, but if this length is higher than the hydra crane boom length, then there must be a road we need to provide near to the circuit breaker for the breaker maintenance. Similarly, till the power transformer, the approach road also would be required for unloading of the transformer and for the installation of the transformer. The same road, here we have the main gate and main access road, which is 5-meter road. So same road be extended near to each transformers around the bus bars. Here we have the bus bar, main bus 1, main bus 2. So around the bus bars here, and from this bus bar we have the hydraulic and boom. So through the boom we can reach till the breakers, and from this bus bar again, like we have to take the crane little bit here, then we can go near to the breaker, and so that we can uplift. So this is what the conventional Indian practice that here we do when we prepare the electrical installation drawing. But I want to like discuss some other country practice for the equipment maintenance. So I'm taking the reference of the UK, and in the UK, the national grid is the main utility. So I have taken the reference of the national grid, and GET, national grid electricity transmission, national safety instructions 8 and guidance. So they are in those utility in those country, in the UK country, when we prepare the electrical installation drawing, along with the electrical installation drawing, we also prepare, sometimes not every time, but sometimes when the bay is very in the limited space, we are doing an extension of the existing substations. So in that case, sometimes as a design engineer, we have to prepare one additional drawing, that drawing called as MUP drawing. The MEWP, this MEWP meaning is mobile elevated work platforms. So what is the meaning of that? Suppose here we are taking again going to this SLD. Now let me extend this SLD. Let me extend this SLD. And now here we have one more additional way. Same way what we here we have, now we have here as well. Just to save the time, I'm not drawing all the isolators here. Same way here we have, right? And we are taking the line out. Suppose now when we are doing the maintenance on this isolate on this breakers, so we, if this particular bay is very much close to this bay, suppose let me take the reverse. I'm doing the maintenance on this circuit breaker, but at the same time my adjacent bay is lying, it is charged here. So we have to ensure that we should not be in the range of this electromagnetic field, like there should be enough gap, enough space between this two bay should be there. If we are coming very close to this bay, in that case, for the maintenance purpose, just for the maintenance purpose, we have to take this bay under shutdown conditions, which is not desirable. So in order to avoid that conditions, when we prepare the installation drawing, we prepare one additional drawing called as the MUP drawing. So in Asian country, we mainly talk about the access road to breakers and bus bar. So as we have indicated here, access road near to the around the bus bar and near to the circuit breaker. But when we go to the UK, whereas in the UK National Grid country projects, we need to provide, we need to produce a separate drawing by the name of mobile elevated platform networks, in the short we call as MUP drawing. In that need to indicate how the vehicle to be accessed, because suppose if there is any entry of the vehicle, so we have to see that how this vehicle is suppose here, just here we have breaker, so how this breaker maintenance to be done at the site. So we have to indicate that the maintenance vehicle will come here, and then it will go here, and then it will go here, and during that vehicle movement there would not be any live conductor. So these all things we indicate through a drawing, which is called as MUP drawing. So how the vehicle to be accessed, and during the equipment maintenance, we have enough clearance from the nearby live conductors have been achieved. If not received, then if not received or achieved the enough clearances, then adjacent bay also have to take shutdown or outage. So this is not desirable. So sometimes we prepare the MUP drawing also when we are doing extension of the existing bay, and in that drawing we take this kind of the layout we prepare. Like if you see here, like here we just indicate that this is here, if you see DS or DSS, this is my horizontal distance or clearances that we have to achieve, and then this is my working platform. So at this platform I'm working, like here if you see here, this is the plate, this access vehicle, this vehicle we are indicating here. So this is my maintenance platform. On this platform we are doing the maintenance, and this is my equipment, on that I'm doing the maintenance. So this yellow line is indicating equipment to be maintained, and this is my boundary of oversealing area. So oversealing area means if you what they are doing actually at the site. So before doing equipment maintenance, if you see they take this scaffolding, right? Could you see here this scaffolding here? So that equipment, they do this scaffolding, means they are entries restricted, means this kind of standard practice we are not doing in Indian country substation project. But when we go to outside, we do a lot of safety measures. So here we like take that I have taken here breaker. So breaker is under my maintenance condition. So here I'm doing this, and here danger notice each and everything. This designates a safe working area Authorized work may be conducted only in this area and only with the approval of the safety document holder. Green codes, these are the placed within the safe working area. These indicate that the area within the red and the white chains is safe. This must not be moved or changed if phone is blown over. Speak to a senior authorized person who allowed to do the maintenance. And now in that area, we take the boundary hot ceiling area, and in the boundary hot ceiling area, we are getting enough clearance equipment to maintain that we indicate here. So this kind of approach also we do in those country for the equipment maintenance, just in order to ensure when we are doing the maintenance of any bay, so adjacent bay should not be affected or that should not be taken under shutdown conditions, because we are talking about that taking the TBC bay, switching the breaker in here, taking this breaker out and rerouting the power supply through like that. But during the maintenance, if adjacent bay need to be shut down, so what is the use of other bus coupler bay, double main bus bar bay if power supply is interrupted? So due to that reason, like if we go in those countries, the power supply interruption is very less, because the safety measures have been taken in the advance. Okay, am I clear with the bus bar schemes which was we started today? So what we discussed today, if we conclude today, what we discussed today, we started that why we required the bus coupler bay. Then we taken a transfer bus coupler, a TBC bay scheme, main and transfer bus bar scheme we have taken, main and transfer bus bar schemes we have taken, and we discussed about the switching scheme of the equipment, right? Then again we have taken a double main bus bar scheme, and we discussed their switching scheme, but their switching scheme we discussed by using the interlock logics, right? So we discussed that why interlock logic is required, right? Why interlock logic is required, why interlock required. Then we discussed that how interlock achieved, right? How interlock achieved. Then we discussed about the BCU, right?
Yes, software in the interlock.
Yeah, software and cable interlock. And then after the BCU, we discussed that BCU take the binary input, binary output, and the interlock developed by using the logic gates, right? Logic gates. So we discuss about briefly about the logic gates, and then we discuss about the interlock logic as well, right? For the equipment operations through the BCU. Right, and along with that, we discussed that even though we are discussing about the breaker maintenance, bus bar maintenance, so when we prepared the layout drawing, we have to provide the approach road near around the bus bar and near to the breaker if my breaker voltage level is greater than 220 kilovoltage, greater than or equal to 220 kilovoltage in that conditions, right? Then we discussed one country, UK country, and there they prepare the new drawing. So why they do that drawing preparations? What is the objective of their drawings? So now the next target, the next point would be the SLD drawing preparations, taking one project and then review the SLD. So I have like received the SLD by, I think, who submitted me. Pawan, I have received your SLD. Direct response to mention a lot 186 is mentioned. Latest version of CBIP manual. CBIP manual was 2006, I think. No, I think 2006. I'm not sure which one is more latest, more than 2006. The 2006 version I have. I'm not sure after that if any other CBIP manual is published. Sir, are you there? Could I review your SLT home, your home assignment? So now back to the project. So I have assigned all of you this project, right? So could I request now take the 220 kV side 2 main bus bar schemes, 33 kV side single bus with bus manager schemes, and prepare the SLD for this. Please work with me on the project so that you get some hands-on experience. And the ultimate goal of all the classes that you should be capable that you can design yourself. This is what the goal right now. So when you will work on that, then you will face the difficulty, and when you will discuss the difficulty, then you will learn. So please prepare the drawing, submit me for the review. And when you submit for the review, please be available to discuss. Like here, I want to review one SLD, but this engineer is not there to respond anything. Anyway, I have seen their drawing. It was quite impressive, and yeah, it was correct. So when you are preparing the drawing, this kind of sketch you can prepare and put the name as well. Put the name as well, so that when I open the drawing. So please prepare the drawing. Just here they have taken one typical bay. So you can take one typical bay, and you can take one typical incomer transformer bay and incomer outgoing bay. Just two kind of the bay, one incomer transformer, one line, and prepare the SLD for all voltage level and taking all kind of the bus bar schemes, and then furnish the BOQ as well, and then prepare the SLD for a complete project. So like they have prepared the SLD for a complete project like that, and submit for the review. So in my next weekend, I will prepare the SLD. Okay. So review all those SLD, then I will prepare the SLD. And after that, I will go to the SLD preparations that I will do, and then the BOQ estimations, and then equipment switch numbering. What is the practice we follow for the equipment designation or equipment numbering, and then system parameters, and then BOQ estimation for one project, and then what is the notes that we should write in one project. So that example discussions, and after that we will go for the again back to the bus bar. And now for the bus bar, this time we will discuss about the bus bar conductor selections. What is the criteria for the bus bar conductor selections, and then after that conductor sizing calculations. Okay.
Okay, sir.
Okay. So I'm now
Thank you, sir.
closing the class. So could we wind up for today, since I have not received the please submit
Yes,
the
sir. Thank you.
assignment. Please submit the home assignment. Okay.
Sir, I have one doubt in Sunday making. Can we place CVT in the bus bar only, or we have to keep CVT every way?
At what voltage level, Vishal?
For more than 132 kV.
Yeah, CVT we have to place in every bay.
Okay. I've seen in the assignment, in the Saurabh's assignment, he keeps the CVT in the bus bar only. So that's why I asked.
No, ideally, it should be placed with the every bay. If in case means in your case there could be a particular reason due to that reason they have not indicated with the line bay. You share me the SLD, and I can speak to you one-to-one. But ideally, it should be placed with every line bay, so that we can get at least the synchro check. Okay.
Okay, sir. Okay.
Otherwise, if we are not placing the CVT on the line bay, so there should be one CVT on the line, and there should be one CVT on the bus, so that we can get the synchro check to close the circuit breaker?
Sir, I have normally seen that in the main bus, we don't use CVT, we use PT. So what could be the particular reason? Is that the precision?
PT we use till 33 kilovoltage, and if you are going above 33 kilovoltage, if in case you are using the PT, so it is not economical in the cost. You are like paying higher cost for that purpose, for that. So
Now in my last substation, it was a 220 kV, and in the main bus, we are using PT for voltage.
yeah, no, there is no any problem in that, Partha. You can use the PT. Okay. There is no any harm in that. You can use the PT. You can use the PT, no problem at all. Even though PT is better compared to the CVT, the error is lower in the PT compared to CVT. Okay.
Yes, sir.
So there is
The
no
same thing client also told me.
Yeah.
Once I asked them. The same thing client also replied. Once I asked them that why you are using PT, we could have used CVT here. They told me that the precision in PT is higher than CVT.
Yes, yes. So there is no any harm in that. Can be used.
Okay.
The client, if agree to pay higher cost as a contractor, what is the problem for that?
Okay.
It's okay.
In 400 kV level, we can use the VT, sir.
Yeah, why not? We can use the VT. We use the VT for the tariff metering purpose, but cost would be
VT.
high. Yeah, come again, please.
Sir, I have a hello.
Yeah,
Sir.
Yeah, yes.
Sir, I have a doubt in the binary input. It is converted in BCU or it is any external devices?
In the BCU. Inside the BCU, we have the device that will come.
Okay.
Sir, generally, if you go for the above 66 kV, we will go for the CVT, right, instead of VT. So in 400 kV, we can use the VT.
Yes, believe we can use the VT, even though when in the 400 kilovoltage, if you are making any renewable solar substations, any renewable power plant, if you are making, in that case, if you are doing the tariff metering or revenue metering, for that purpose, we use the metering CVT and metering CT and metering VT, and that metering VT is simple EMVT or IVT. So yes, we use, but cost would be higher. That is the only reason. There is no harm in that. We can use. I think the drawing. Let me see. I have taken a snapshot of the 400 kV SLT. In that we have discussed about the. In that we have taken the 400 kV. It is not clear. It is not clear. Yeah, we can use anyway, pulley.
Okay, sir. Okay, sir. And one more thing, sir. It may be maybe
pulley once. No fall. Could you discuss with me one-to-one regarding the
yeah. So okay, sir. Okay, sir.
No, not you. I'm telling to no fall. No fall. Who's no fall? And you have cable. Abu Hamid, please discuss with me one-to-one. I will clear your doubt. Okay, Abu Hamid.
Sir?
Yeah, discuss with me one-to-one.
Hello, sir.
Yeah.
I have one doubt, sir. For example, if we have 2 voltage level in the substation on in the 400 in the same 400 kV substation, there will be a 132 kV also. So as far as protection concerned, we can So for the tail end protection, for 400 kV we are using. For the tail end protection is applicable for 132 kV also, or only for 400 kV, sir?
Please once again repeat it.
For example, we have the gantry, sir. Okay, we have the gantry where the takeoff structure is there. Okay, where the takeoff structure is there. The takeoff structure, after the takeoff structure, it will connect to the terminal tower, dead end tower. Okay, before connecting the dead end tower, we have the gantry takeoff structure. In that takeoff structure, for 400 kV, there will be outdoor equipments like surge arrestor and surge arrestor and
Here we have
surge
the
arresters.
similar drawing of believe
Yeah.
what you are telling. Here we have
Yes.
the similar drawing. So here we
Yeah.
have the dead end tower, right?
Yes, sir. Dead end tower.
Yeah, here we have the structure, guaranteed structure, and here
Gantry.
we have the equipment suggested CVT.
Suggestion CVT. There is no CT is required, sir. Or
there is no CT.
No CT, because for example, the bay which your cursor is there. The bay, for example, if you are considering as a outgoing bay, OHTLP. Okay. Okay. In that case, you are just the bay is going out. Okay. In that case, after the gantry structure, there will be a surge arrestor, because it is a reverse. The drawing which you are showing, so which you are showing as a reverse. I mean that you are taking the
First of all, we decide equipment. Due to that reason, we preparing the single line diagram, because we in the SLD we decide whether this equipment is required or not required. If we have taken in the SLD the CT equipment, then we have to place over here. And now, since you were talking about the 1.5 breaker scheme, so in the 1.5 breaker scheme, we have discussed that we have 3 CT scheme, 4 CT scheme, and 6 CT schemes, right? So you have to see that which CT schemes you have followed. And if in case you have taken the metering CT and metering VT, then the metering CT and metering VT would be required. But that metering CT VT, if in case you are using the wave trap or line trap, so this metering CT and metering VT should be before the wave trap over here, because from this, if in case you are doing the power line carrier communications, if in case you are doing, then any of the 3 phase you are choosing for the carrier communications, right? And
no, sir. My actually my doubt is, for example, here. For example, here our line is coming as an incoming line here in our case. I mean that in the drawing which you are showing, that is an incoming line. So we have the starting equipment as a surge arrestor, after that CVT and other the further equipments. So my case is different. For example, this is you are showing the gantry structure. Okay, this is the gantry structure. In the right hand side, is our switchyard, our main yard, and from the gantry structure, the line is going outside instead of coming inside. The line is going outside. Okay, one outgoing line bay you can consider as. While going the bay is while going the outgoing, first we will put the surge arrestor. Okay, and after the surge arrestor, my question is, after the surge arrestor, there is a CT required or not?
Here?
Yes, sir. Yes, sir. Yeah. This place. So, for example, yeah, this place CT required or not? My doubt is whether the CT is required in this place or not. Before that CT, the surge arrestor will be there. Okay. After that, the surge arrestor.
Here it is not required.
Yes,
Here
sir.
you have to place the CVT. No CT.
No CT in that because as per the specification what we have received from client, they are saying that there should be a CT required for the tail end protection. Tail end protection for the 400 kV line.
See. CT would not be here. CT should be after the disconnector. If in case you have the wave trap, then before the wave trap, and if in case you don't have the wave trap, if you are not using the wave trap, so CVT first will come. After that, you can take the CT, and that CT we take for the T protection.
Okay, T protection, that's CT. Okay.
Yeah. For that purpose, we take the CT for the T protections. are
Okay.
stub protections that majorly the T protections we take. So
Okay.
we do in that case, what we do in that case, I will take any T protections single and diagram so that I will explain you.
Okay, sir.
To be on to be quick, reply that what we can take like a isolators and circuit breaker here, isolator breaker, and then we can take CT here, and then we can take a 5-core or 6-core CT here. Okay, and then we have the line isolators, and from that there is an outgoing line. Okay, and then
Yes,
again
sir.
we have the line isolator, right?
Yes,
And
sir.
then there is outlet. So what it could be done that we can take a CT over here. Okay,
Okay. Okay.
CT over here we can take, and what we can take, like here we can do the bus bar protections are I think bus bar protections could be done from here, the bus bar protections, like we have to see that till where we are, we want to cover, like till here or till here, means this CT we can use for the bus bar protections, and
Okay.
from here to here till here, okay, we can do the T differential protections. T, 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 87 T differential protections from here to here and from here to here. This would be metering, and from here we can do the line protections. So if your client is asking a particular separate T differential protection, in that case, at the exit point, one more CT you have to take. But that CT again will come before the CVT. And I think I have to check once that this CT we take before the isolator or after the isolator. I will check the CT. But yeah, coming to your case, this, if you are considering the CT over here, so that CT, if it is not for the tariff metering purpose, if you are using for the protection purpose, then that protection purpose we utilize a T differential protection. For that we take.
Okay. Okay.
Yes.
Okay. Thank you, sir.
Okay. Yeah. Any other?
Yes, sir. Yes, sir.
Any other query? If no, we can round up this. So again, let me repeat the home assignment for all of you for this week. So first home assignment, take one transmission line bay plus take one transformer bay and take all kind of the bus bar schemes and prepare the single line diagram. Second assignment is what we discussed here. Second assignment, where is the second assignment? Yeah, this is your second assignment. So prepare. So actually what I'm trying to do, I'm trying to take one project parallelly. Okay, so what I will discuss during the classes, I'm trying to apply those learning in one project, so that after the 4-5 months we have a complete project drawing prepared. Okay, so take a 220. So I'm taking a 220 by 33 kV, or you can take reverse conditions 33 by 220 kV. This is also you can say. So 220 by 33 kV, and this project is a renewable power plant substation project. So in the renewable power plant substation project, we are generating voltage, and then we are stepping up till 33 kilovoltage, and this 33 kilovoltage we are taking, all 33 kilovoltage feeders we are taking, and then we are terminating on a common bus bar, and from that common bus bar we are connecting to the power transformer, and in this particular case they have taken 150 MVA 2 number of transformer, then step up into 220 kilovoltage level, then connecting on 220 kV bus, and then taking a 220 kV transmission line bay, and that 220 kV transmission line they would connect here, and this 220 kV transmission line will be connected to the to the grid substations, and this grid substations would be the part of the entire national country grid. Through that, whatever the power you are generating through the renewables, so that power you are injecting into the total country level grid. This is what the reason of the renewables solar power plant generations. So this is what to feed the power, we need to create a substations. The same substations, as you can see the drawing that I was indicating you through the Google Earth coordinate here. If you see, just going back, so here if you see, I have solar power plant. Now in the solar power plant, I have the solar PV modules. Through that we are taking the sun rays, and through that we are generating the power, and this power generated into the DC voltage, and with help of the inverter converting DC to the AC, and that AC conversion is again very less, like in the range of 600 or 800 voltage AC. So that AC we are feeding from the inverter to the inverter duty transformer, which step up the voltage to 33 kilovoltage, and from the 33 kilovoltage we are taking up power, and then we are connecting all the power at 33 kilovoltage common bus bar that you can see over here. We have done the common bus bar 33 kilovoltage here, and here like we have different 33 kilovoltage feeders that which is coming. Then we have 3 number of the power transformer. Due to that reason, here we have 3 number of the transformer wave, and then this transformer step up a power at 220 kilovoltage. Since we have 3 transformer at the here, so there would be 3 number of the HV bay as well. So one bay here, second bay here, and third bay here. And now we need to transmit power to the remote substation. So we have a transmission line as well. So this particular way that you can see, this equipment is extended. So here we have the transmission line. And now if you see, here we have the transmission towers, if you see here. So tower 1, then you need to spot like here, next tower where it is coming, next tower over here, next tower over here. And there would be one next tower over here, next tower over here. So this is the route survey to be done, and through that we do the tower spotting through the ROW, and then there would be nearby after 10-15 kilometers there would be a remote grid substations. There would be a nearby anywhere. It is not appearing in Google Earth as of now, but there would be a now here Tata Power Solar substations, their substations over here. And now if you see here, they also have their switchyard, right? They also have their switchyard somewhere. Could you see the switchyard over here? Could you see their switchyard over here? This is control room building. They have transformer here, and now they have their own switchyard. Now they have their own transmission line. So what we are doing basically, we are discussing how to prepare the drawing of this kind of the switchyard, and SLD is the first drawing. So in the SLD we take different bus bar schemes. So that bus bar schemes discussions now we have done. So now we are ready to prepare the SLD, right? I hope my home assignment is clear to all of you. Right?
Yes, sir.
So please,
Yes, sir.
please submit. I'm waiting for all of you home assignment. If you will not submit, then I have to go along with the syllabus, and then I will keep discussing the next modules. But in that, if you're not working on the project, you will not. How you will see that whether you are learning, is it okay or not? Ultimately, goal is the drawing process. This is all the process through that we are reaching on that. Okay. T difference.
Raghav, I have one question.
So now T difference.
Thank you, sir. Thank
you. Okay. Okay. So
Raghav.
Yeah.
Yeah. So sorry. After 1 month, I have joined back again because of some duties. I have one question regarding this the home assignment what you have given. Can you just share that specification so that I can prepare also the SLDs?
This specifications, I will check and I will try to remove any header and footer, then I will try to share, okay?
Yeah, how did you share this with other
I have not shared so
attendees?
far. I have not shared so far. I only have shared this snapshot of this scope of work, but I have not shared others. I will do
So
that.
we have, oh, okay. If you just
I have not shared, I have shared the snapshot in the WhatsApp group like that only.
I think in our group only, correct?
Yeah, I think a few students have asked me, so I think to those students I have shared one-to-one on their WhatsApp number. I do one thing, I'll take the snapshot and I will share to our WhatsApp group as well. I will say,
Okay. And secondly, like in the grid, national grid, what we are saying. So just want to understand. Okay, let's forget national grid. Like in a small distribution loop, like we are having some radial connections are there and some are closed loop. So in the closed loop, if we are distributing power supply through RMUs like that, so the first power supply from one feeder from the substation, if it goes to RMU and then another RMU and then come back to the same substation and connected in the different bus, like bus A, one feeder, bus B, another feeder. So this loop closed now. So is there any issue that if we keep both feeders close and power supply continues, there is no problem, correct? There is any dead short circuit, anything?
No problem.
So like in bus A, I have one feeder, okay, that feeds to my first RMU and that continues to second RMU, third RMU like that. And the last RMU end, it goes back to the substation in bus B section. And there is one feeder I'm using to connect to it. Now, this loop is closed now. So, because in our project, what we are doing, we are keeping somewhere RMU side open, one end open. And power supply is feeding from both ends from the substation, bus A and bus B. So if I close that RMU in middle somewhere, so is there any problem? The power supply continues, correct? It's not short circuit.
Yeah, I don't think there is any issue with that. To be honest, whether if I want to comment anything particularly, it would be better if you can share any snapshot, any picture of your SLD so that I can see the entire picture. Then, if I comment anything, will make the sense, right? Whether
Okay, I'll take a snapshot also.
yeah, because
and
I'm not
and I'll share with
familiar
you.
with the whole system, so it is not good if I comment anything and you follow my statement and you go ahead. Sir,
Okay. No, just like a normal, not only this project I'm saying, like if we have, just now you showed me Tata Power, let's take one grid from Gujarat is going all the way and feeding in Maharashtra, and from there, Maharashtra, it is going back to Madhya Pradesh, and from Madhya
no,
Pradesh
there
going
is
back.
no problem in that, no problem in that. Yeah, if you talk about
So,
the grid specific level, if you're asking, so I can tell there is no problem in that.
So we don't need to keep anywhere our transmission line any side open. So it can continue, correct? It can be a
Yeah,
closed loop, correct?
yeah, correct.
Okay. Okay.
The voltage and the frequency should be same.
Yeah, it is same. It is same. Voltage
Yeah, no
frequency
problem.
is same.
We are also
Okay.
here, we are synchronizing the grid.
Yes, exactly. Okay. I'll share also the snapshot, Raghav, and please share me this one so I prepare the assignment. Thank you very much.
Yeah, I will share, brother.
Sir, I have shared in the group some CBIP manual.
Oh, that's
okay to go ahead?
That's great. So yeah, manual person general. Yeah, that's very good. Thanks, Dennis. Yeah. So what you were telling, Dennis, now?
No, just I'm searching whether this is in line with our course content. I am looking for this.
Yeah.
No, this is only for the reference only, sir.
Yeah,
Nothing else.
thanks for sharing in the group to all of you. Yeah, it's lying in the course content. Yes. Yeah. So we are taking the topic wise topic and we are discussing on that.
Hi, Raghav. Can I
Okay.
ask you something?
Yes, sure. Why not? That's why I'm waiting for you.
Yeah.
Yeah.
So, I mean, since we have joined later on, and we have a few students in our group, so is it like okay to create a common group where we can share our experiences and anything technical or any queries we have, we can
We
answer each
already have the
other?
group. We already have the group.
Yes, but we are only few people in our group 2B or whatever you call it. It is not all the people, I guess. So our group is different, I guess. So it's not, we have only few members in our WhatsApp group.
You have your own WhatsApp group.
No, you created a group which is named as 2B, I believe. Let me tell you the exact name. Yeah, this is 1A and it has got,
Yeah, so no problem. You can share the materials.
it has got, now like in our class, there are 60, 70 people, but in this group only, let's say 15, 20
Yeah,
members are
no
there.
problem in that. You can share. I think there is no any restrictions in that. Anyone can share any material there. There is no any like permission required. The group is open, right?
No, I'm saying if we can create one group where everybody can share their experience and queries, so it will have more people, more participations, and yeah, that's what I mean.
Actually, that we can do. Allow me some time because a few person joined earlier, a few person joined later on. So, when it comes on equal stage, I'll try to merge the group in one group.
Yeah.
Okay.
Okay, so we'll be waiting for you to share this spec, right? So that we can all make the same SLD for the same specifications. Right?
Yeah.
Yeah. Okay, thanks. That's all.
Yeah, thank you. Thank you. Yeah, okay. So if no query, we can close for today, and next Saturday again we can meet and we can discuss the SLD preparation directly now. Okay.
Yes, sir.
Dennis. Yeah, okay. Thank you. Thanks all for joining the class. Thank you.
Okay, sir. Thank you, sir. Good night.
Thank you.
If anything I could not reply to anyone, please do not hesitate and please call me after 2-3 minutes. I'm open to discuss again.
Okay, sir. Thank you, sir.
Okay, sir. Thank you.
Yeah, so you can call me after 2 minutes and we can discuss one-to-one as well if anyone have any further query. Okay, thank you. Thanks.